Hey everyone, and welcome to this first session or introduction session into 90 Days of DevOps. And basically what we're going to be talking about is the 90 Days of DevOps project that I started on January the 1st, 2022. And that goes for 90 days consecutively until March the 31st. But ultimately the idea around this was to give us a roadmap per se. There's lots of great roadmaps out there already from other people within the community, but I wanted to, or I had the reason to fill in some gaps myself. So this is really about why, and also then to dive into some of those individual areas. And then the idea is that we can take other sessions, other videos, other bits of content, and dive a little bit deeper into each of those. So let's jump into it to begin with. So first off, who am I? So I'm Michael Cade. I'm a senior technologist at Veeam Software. So I've been here for just over 7.5 years, and my focus obviously has been around backup, data management, and everything that goes alongside that. I think when I first joined up, I was an SE when I first joined, and I was very much focused around that infrastructure, around storage, around virtualization. Then probably around 18 months ago, I was given the opportunity to learn more around our cloud native strategy and technologies that I do get into here, but really that's not the focus of this. I've got a lot more content coming around the Casting K10 by Veeam, which is Kubernetes backup, Canister, which is an open source framework for application data management, Kubester, which is there for storage or simplifying the storage in Kubernetes. Obviously, there's a lot of stuff around Veeam as well. Also, to go hand in hand with some of this focus around the cloud native and the cloud native community, I'm a HashiCorp ambassador, have been since the beginning of that program. Namely, and we are going to cover a lot around infrastructure as code, which I do use Terraform and have done for many years. EddieHub as well, from an open source contribution collaboration point of view. Open UK, focusing around open source community, hardware, software, etc. Vzilla, I would say I've been less active there. It's been more about virtualization and storage on that blog post. And some community focus. I would say actually the large majority of my writing at the moment actually happens on GitHub, which if you click that QR code in the middle here, you'll be able to see the 90 Days of DevOps, the repository that goes hand in hand with this. And I'm going to get into a little bit more detail around that as we go. But to begin with, I think it's fair to say is that, and this is obviously only a snapshot of some of the logos, vendors, tooling, projects that are out there within the DevOps space or within the cloud native ecosystem as well. And I think overall, like if you were going to be asked to go and learn all of these different areas, bearing in mind that I come from that infrastructure and operations background where you would probably focus on one storage, one virtualization platform, maybe get into that one cloud. But generally speaking, I come from that. I'm going to know NetApp storage. I'm going to know VMware from a virtualization point of view. And that's probably enough to be the master of my infrastructure admin days and looking after everything within that. When you open up the door to cloud native, DevOps, and all of the other platform engineering, SRE, you're going to have to know a lot more about a lot more things. And I think the key here is that you're not going to be a master of all of these or any of these. And the idea is to be a jack of all trades when it comes to, or have the awareness of it. And the idea around the 90 Days of DevOps challenge that I set myself, and really if you think about that, that was 90 days of me writing out notes, running through some hands-on stuff, bit of theory, but it was about me understanding and filling in the gaps that I needed and having that foundational knowledge, that awareness of each individual section within that. But I think it's fair to say that if you look at that long list, and that again, that's only a snapshot of some of the logos, I think it's fair to say that we can be massively overwhelmed. And to be fair, a lot of us would jump off the learning curve or the learning journey maybe at that point, and we don't know where to start. So this is really another aspect of this is just giving us an idea of where we could go. I'm not saying you have to start from day one and finish on day 90, because some of these areas might not be of interest. But I'm just giving you my background, infrastructure operations, more moving into the cloud native technology ecosystem with a DevOps focus around automation, with the principles and process, and then adding the tooling on top of that. So why did I do it? Well, that comes down to that role change and the focus around that. I have a bit of existing knowledge. I've mentioned Terraform from an infrastructure as code point of view. I think the key there is infrastructure as code can be used regardless of platform. So whether you're using generally like any virtualization, any cloud native, you can use infrastructure as code, and which is one of the topics that we cover. I'd also done a bit around configuration management using Chef. I actually use Ansible as part of the 90 days because I feel like it's more broader than Chef per se, and maybe a little bit easier to grasp, at least in my experience. So I had some areas where I had good knowledge, and I would also say things like networking was another area that I had a good idea around, and same with Linux. But there's always more you can always learn, right? You could spend 900 days on Linux and still learn something new every day. So again, this was about just bolstering what I already had and making myself a little bit more accountable from that. So what was already out there, obviously there's a ton of content, whether that's video content, whether that's written content. There's a lot of free and paid, and my emphasis here was about making sure it was free. I think there's another craze around, and I use craze in the nicest possible way, and that there's a lot of great projects out there around 100 days of XYZ, 100 days of Kubernetes, 100 days of this, 100 days of that. For me and how I learn, that just wasn't. I even tried 100 days of cloud. I think I got to day 36 and gave up. Like, it's just too much to think about. Whereas I don't know how I'd managed to do 90 days, but bear with me. I think it's fair to say we've probably all heard of Udemy, and we've definitely all heard of YouTube. I found that YouTube was my go-to when I was looking at this, and one thing you'll find throughout the whole repository is that I use on every single day, scroll right down to the bottom, and that's where the smart people are. That's where I'm learning from. There's a list of resources on each specific or particular content area that I'm focusing on for that day, and I'm diving into their content and I'm learning from their content. But I think it would be remiss as well to not talk about things like Udemy or Pluralsight. But I think it's also fair to say is that Udemy comes around, it's £12 for a session. But you can see here that I've done one that's 97%, and then the rest are pretty much that we haven't done a lot of the others. So I think that's another reason why we might buy a lot of these courses, but unless you're going to do them there and then, or at least in the next week, and you're disciplined enough, then just stay clear of them and look at the free. There's a hell of a lot of great content on YouTube itself. Okay, so the challenge was to get a better understanding and a foundational knowledge of the areas of DevOps. Now, DevOps in itself, I've chosen 12 areas. We could easily choose another 12, and in fact, that's probably what we'll get to by the end of the session. Is I'll be a little bit more open about where we're going to go potentially for the next 90 days. But if we think about the DevOps, but let's think about the processes, the principles, the tooling around that. And probably the most important is about sharing that journey, learning in public. Now, obviously from day one, I never expected anything like the coverage, the social media coverage that I managed to get around this repository, the amount of contributions where the amazing community come and help with my spelling grammar from a base level, but then also challenge me on that. Challenge, if I've said something and it doesn't quite ring true, then I've had some awesome community feedback, community contributions around, oh, actually we should just tweak that a little bit, or what about this as a perspective? And I think that's massively important. And the amount of people that have forked the repository to go and live their own journey and do the same thing is also pretty incredible. So how do I learn best? And everyone's going to be different here, is watching video content, writing down my notes, and then getting some sort of hands-on. So you can expect throughout that whole 90 days is there's a lot of me watching something, pushing that into some sort of note form. There are some like slides that I create as well, because I wanted to put notes in picture form, because I find that easy to reference later on. Get some hands-on with some of that, like every single technology that I talk about, every single bit of tooling I talk about within there, I generally get some hands-on. So with Ansible, with Terraform, with the cloud, I get hands-on so we can actually show it. Push that to GitHub, this repository that I linked at the very beginning, and share with the community. Learning in public is massively important. So that's the idea. That's what you're going to see throughout. Just to hone in on that, learning in public. Like, we're never going to be done learning. So don't believe, don't ever think that, oh, once we get through this, we're going to be done. That's never going to be the case. We can continue to keep learning and diving into more areas, or to hone in on a particular area. Depending on if you are a writer or not, then think about how you can learn in public. Blogs, tutorials, cheat sheets. I've seen some amazing content, especially on Twitter, in a much smaller form, where these cheat sheets, and they're not cheat sheets as in, like, they're not giving you heads up for any exams or stuff. But if you think about Git, for example, Git has a lot of useful commands. They have a never-ending amount of commands, but there's some that you will use every day. If you're using a Git-based service, such as GitHub or Git within your local machine, you are going to be using Git. You're going to be using Git add. You're going to be using Git commit. You're going to be using Git push. You're going to be using Git pull. And just having that cheat sheet that I've seen some amazing ideas around that on Twitter, like, put one of them together. It's simply a slide that has all of that information. I say speak at meetups and conference, but just attend them. But because I feel like we're learning. But share your journey. Like, one thing here, this 90 days of DevOps, this is me just sharing it. If it's useful, brilliant. If it helps one person, I believe that it's well worth doing, right? That's my key. And if this has helped more than one person, then brilliant. But that one person, if I've helped them with a foot up, a bit of direction, then that's my job. That's my role within the community. I take enough out of the community, so I wanted to give back to that. Be helpful, like, ask and answer those things on Stack Overflow or Reddit, but simply just like be on Tech Twitter and answer those there, and different forums, different Discords, Slack. I have my own opinions on Slack and Discord. I feel like that's a lot of hidden stuff away from the world. It's not searchable from a Google perspective, which means that we could be repeating ourselves quite a lot out there. I'm more over for the live and public facing forums, but obviously I'm not in control of that. So we know that there's Slack, and we know that Discord groups are out there. And make videos, make those Twitch streams. I think the pandemic taught us one thing, is that we can very much be addicted to watching YouTube videos or getting on Twitch streams. It's another way of being able to consume a lot of content very quickly without really having to write and read. But whatever it is, and like, obviously this is DevOps focused. You might be a programmer, you might be a Linux expert, you might be a network administrator, but make the thing you wish you had found when you were learning. Like, one of my biggest things is roadmap was important. It's quite interesting that there's a few roadmaps that came out around the beginning of 2022. I feel like this is, it was something that was missing. How do we hit the easy button to get into DevOps and understand more about what DevOps is, how it can benefit our business, blah, 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 but also around the tooling process principles and etc. around that. Okay, so we take that overwhelming image that we saw at the start, and what I did was I took 90 days because it's less than 100, which meant my brain could compute that, and we could definitely see the finish line, although there was a few days in there, I must admit, where maybe things were a little bit overwhelming in itself. So we start off with what is and why do we use DevOps, And then this is where we can break away. Like, I started with learning a programming language. I've never been a programmer. You're not going to be a programmer after going through these 7 days of programming language, but it will give you a good understanding of what it is, why we do it. And then you can go further into that. Like, so me in particular, Go is what Casting K10 is written in. So having an understanding of that, as well as some open source projects that I'm interested in, they're also written in Go. So having not necessarily the ability to write in Golang, but having the ability to read Golang and why are we getting there and what are we trying to achieve with that. But if that's not your thing, then jump around. Like, all of these are 7-day chunks, if you will. So if you wanted to then go into Linux and understanding the basics, what a terminal looks like, what are some of the commands there, what is it like, I would say, yeah, dive into that. If you feel like you've been very much focused on Windows, maybe as an operating system, which I know a lot of infrastructure people are, then jump into knowing Linux basics. It's very much, and just quickly on that, my journey was convert a laptop into it, because that's going to give you the hands-on experience on a daily basis. So for the first 90 days of 2022, my daily driver, everything was really about using Linux on the daily. Understanding networking, so things like DHCP, DNS, it's always DNS, but really having an understanding of that, and then building in the automation around that. What does that mean? Like, how do I automate networking? Because ultimately we have to live and breathe that same model. I say about sticking to one cloud provider here. So I use Microsoft Azure. I went out and asked Twitter what cloud provider I should use, and Azure came up on top. Obviously gets a lot of requests that we should do the same for AWS and for Google, for Oracle, for other clouds, which is great. And we might be able to do something in the future around that. But my idea here is that if you can learn the fundamentals, the foundations of Microsoft Azure, and understand what that compute, that storage, that networking model looks like within the cloud, then you could pretty much take that foundation and you can, in my opinion, you can go to AWS, you can go to Google, and you can get by. You can do enough damage. I think very importantly, understand Git. I don't think you need to be a developer to understand Git or to have that in your armory. By far, this is the de facto version control system. Also, I lived and breathed, I ate my own dog food by this whole repository is obviously Git based, using GitHub as my repository. So versioning that and having that, and then starting to put other areas of my day-to-day in there, presentations, etc. So that I've got different versions for different environments, different branches for different events, maybe. Then we start to get into a bit more of the platform. So I wanted to make sure that I did have a very strong understanding of containers. I went into Docker. There is some information around other containerization or technologies around that, but Docker being the de facto, if you will, or at least how there's the most content around that. So I wanted to dive into that. Kubernetes is another. Now, you could quite easily take over and do another session on virtualization or another platform. Doesn't need to be VMware, but it could be just a virtualization platform of your choice. You could then start to look at things like OpenStack with KVM and other areas around that. Then we get round to a bit more DevOps focus, but think about the platform is still very much a focus for the DevOps teams or DevOps focused engineers. Learn infrastructure as code. I use Terraform, but we still touch on other IAC tools such as Pulumi. We don't necessarily get hands-on with that, but it's something that I want to get more involved in. Then go a bit more focused on the application. So we're looking at the automation of configuration management, and in particular using Red Hat, CI/CD pipelines, using Jenkins, Argo CD, GitHub Actions. So getting really into it very quickly within that section. Then we get into probably and I've purposely put them at the bottom of the list because I feel like we always do. One is observability, and that gives us the visibility around our login, our metrics, our monitoring, and then finally around storing and protecting that data. And I talk a lot so there's casting in there a little bit, but I also talk about a lot more open source tooling, as I do throughout this whole piece, that all of the resources, unless I've stated, are free and open, generally YouTube videos. The tooling that I'm using is generally free and open source, or at least a free and community edition version. And that goes throughout the whole session. So though that was me breaking it down, I think what is and why do we use DevOps is maybe 6 days to begin with, maybe 5, and then the rest are 7-day chunks. So you can dive in, you can dive out, and go wherever you need to go. Okay, so the idea of this session isn't to go deep into the weeds and get into we're not going to spend this session just to go through what is and why do we use DevOps in as much detail as we do in the repository, because I want to go through all of those areas and think about that as a bit of an agenda for what we're going to go over for the next 30 minutes maybe. But we need to have a better understanding of this, and then my idea would be is that we'll have a separate video that goes into a little bit more detail around this. So if we think about responsibility of a DevOps engineer, and first and foremost, I should have put an asterisk up there, is that although the industry's done this already, is that we do have DevOps engineers as a role. In theory, we shouldn't necessarily have that role title, but we have, and that's the way it is. So there's a caveat there in that you don't have to be a DevOps engineer. You could be a solutions engineer, a systems engineer, a cloud architect, cloud engineer that has these responsibilities. And I generally believe that the sysadmin of today in 2022, in the next 3 to 5 years, will have to have this mindset and have to adopt a lot of these technologies. By all account, maybe not all of them, but you will have to have that mindset of a DevOps focused engineer. So if we think about DevOps being the link between the two, so developers, platform, or operations, and developers. But that doesn't mean that you are going to be writing the application. I think I get into that a little bit more detail as well, especially in the repo. The idea is, let's get away from that master of anything in particular. I keep using the Microsoft Exchange admin as that example. If you were an Exchange admin and you were focused purely on making sure that Exchange was up and running, scaled accordingly, performant for your end users, then you've had to transition already in the last 10 to 15 years into something else, because there are going to be, well, there's not many masters of Microsoft Exchange roles out there. So I think that's the most important part, and biggest advice that I can give is that we have to think about being a jack of all trades. How do we know a little bit about a lot of things? Yes, we could still be a master of networking, and yes, we could still be a master of Linux, but we need to know the broader DevOps tooling principles and processes around that. And get this mindset in, because this is where we're going. Everything starts with the application. We have to be thinking about what the application is doing. Doesn't matter what platform we're running on. Could be physical, because we've still got physical systems out there. Could be virtual, could be cloud native. All of them, we have to start thinking about the application scale, the application availability, the application backup and recovery around that. But and also the observability of that application. So if we think about the DevOps lifecycle, again being application focused, and we think about continuous everything, gone are the days, or at least hopefully gone are the days of that release cycle of being 6, 9, 12 plus months before we get version 2, from version 2 to version 3, and so on. I also strongly believe, like, if we think about continuous integration, continuous delivery, and this is just touching ever so slightly on that CI/CD pipelines, is that the DevOps focused engineer is not going to be creating the application. They're not going to be running through the development, the testing, the integration. Now, you might be building the systems that enable the developers, and that's all well and good if you're in a software house that is running through that. But I would also argue that the majority of us are going to be taking off the shelf software, which is where we get to the right of that. And how do we automate everything. How do we automate the configuration, the hardware, the platforms, the user experience, and that feedback back into our developers so that we can enable them to have a better understanding of what our users are wanting from our application, whether that is internal users within the same company or external users out and actual customers. So I think, we're definitely seeing applications that we've always had off the shelf, Microsoft SQL Server, Oracle, for example, as data services. They're now containerized as well. So you choose then, where do I want to run it? I can run a database of Microsoft SQL Server on physical hardware. I can run it in a virtual machine. I can run it in the cloud as a virtual machine. I could run it as a PaaS-based service. And I can also run it in Kubernetes, for example, or inside a container. So we need to then make that choice. What's best for our application at that point, and where are we going to benefit the most from that? And it's going to be down to the DevOps engineer to make that decision and be more application focused about where that lives. Then we've got to think and kind of live and breathe this plan, code, build, test and release, deploy, operate, continuous everything. How do we continue planning, continue the code, continue the build? And again, we're not going to be creating the code, but we need to be able to potentially understand a bit more about it. And this is why I started with that learning programming language. And then we are going to definitely be involved in that release, that deploy, that operate, and the feedback wheel of bringing that back into the developer. Even if it's not a developer and we're just taking it from Microsoft, for example, off the shelf, which I believe, again, that we're strongly going to see, is we need to be living and breathing that. Okay, so I said it was going to be quick. So learning a programming language. I chose Go simply because the products and the projects that I look after, or the ones that I'm interested in, are written in Golang. And it's quite easy. In fact, in the big picture, the first day of every section is defined by a big picture, is that I talk about why I didn't talk about Python. But I think if I go back, I would definitely do learning a programming language, the Python version. The big picture of that, do you need to learn it? Well, that's up to you. Are you in a software house where they develop? If not, you probably don't. But then also think about, from a DevOps point of view, you actually might be writing some sort of tools, but tools that enable your automation to run better. You're not going to be writing the application, but you might write an application that enables you to do more, like a CLI or some sort of program that enables you to move something from A to B, or do something that automates your day-to-day. I chose Golang. Obviously, I've given you that reason, but also think about all the other cloud-native tooling. So Docker, Kubernetes, Grafana, Prometheus. Obviously, I've mentioned Kasten because I work there. But ultimately, they're all written in Go. So that cloud-native ecosystem is written in Go. Now, another one that we could throw in the mix here is Python, which I've mentioned, which is very broad in terms of where it can be ran and where it can be used. And that might be the right idea from that. Now, if I was going to take that cloud native mantra again, is I would probably also look at Rust or something along them lines. But just a snippet, and again, we're going to go deeper into these areas later on in further videos, is Go is a compiled programming language. Go compiles directly into a machine code. Go is known for fast compilation times. Biggest win for me on Go is that I can use a Windows machine to create any binary. I can do it for then push it to Linux. I can, and it's much simpler than, say, something like Python, or at least for me it seemed that way. So that's really the big picture as to why. If we just quickly look at like a simple Hello World app, which I actually run through, so if you wanted to go through this, you could see that in the repository. So a simple Hello World Go binary would look something like this. We'd have our package, our import, and our function, and we would have a package, and this file belongs to the package main, so every project would have that. We would then say where we want to start the execution, and then we would choose on what other packages we are going to bring in. Now I'm using FMT because that's what allows me to do that print in, or the print line of hello 90 days of DevOps, and you can see that running. I've written other little Go packages or Go binaries around. I actually use it as part of a GitHub action to tweet out when a new PR is merged with the repository. So we write out to standard output. So that's kind of, again, we're running very quickly through this, but this kind of hopefully gives you a bit of an understanding of where we're going and what we get into in each of these. So again, the big picture around Linux. So if we think about Linux and DevOps, they share very similar cultures and perspectives. Both are focused on customization and scalability. No one's, or at least it doesn't have to be, is a Linux desktop never has to look the same as the partner or the neighbor of that. Like, we can be very, very custom when it comes to Linux. And in fact, the last day of that is me doing a YouTube video of actually how I customized my Linux distro using Ubuntu, and anyone can play along with that. I basically use VirtualBox to spin up an Ubuntu box to play around with. Another important bit, a lot of technologies start on Linux, and you're going to see two down the bottom that are also written in Go. But they start on Linux, especially if they're related to software development or managing infrastructure. So if we think about Docker and Kubernetes, both written in Go, but they were both written with Linux in mind. Like, let's leverage the technology underpinning. Granted, yes, you can get Windows containers, and yes, you can run Kubernetes on Windows. I don't know. I've never seen anyone doing it in production, but let me know if that is the case. But then also think about like Ansible and Git itself. They were both written with that in mind, but we actually run Git in any operating system. We can run it on Mac OS, we can run it on Windows, as well as Linux, obviously. But it started life out as a Linux focus. So, and then also if we think about open source projects, especially DevOps tools, so thinking about, from my world, like the Canister, the Cubester, they were designed to run on Linux from the start because I want to be able to run them there. So that's another big tick in the box as to why did I choose Linux over Windows. Windows I spend most of my time in, so I'm pretty au fait with it, and plus it's pretty simple, pretty easy to understand for me. I've been doing it for over 15 years with Windows. Now, this goes back to the point I made earlier about if you want to learn something, then you have to get hands-on with it. So this is my call to the community. If you want to learn a bit more about Linux itself, convert an old laptop and install Linux. Now, everyone has got access to a laptop. I appreciate that. Build a VM or a cloud instance. Use the free tier. Has anyone got a Raspberry Pi or some sort of mini computer at home that they can deploy a Linux variant, a Linux distribution to? And then more importantly, and the actual challenge, like anyone could do the above, right? Anyone should be able to do the above three. We have free tiers in any of the clouds, so you should be able to take that. But the challenge that I'll set out is, could you take up Linux and use it for work for a week? Now, my big excuse there is that, so I've managed to. Now, my biggest pull factor, though, is that we use Office 365, Microsoft 365. So I'm torn in that I have to use the web apps. Some of them aren't as good. Now, you could run a Windows VM within Linux. That's a bit of a pain. I actually don't do that. I use the web apps, but I also have access to a Windows desktop as well elsewhere. But I think the biggest takeaway here, and this goes for the whole repository, not just Linux. Linux is the easy one to get on with. But then you have to get hands-on with it daily, whatever that may be. Like, so Ansible, Terraform, CI/CD pipelines, like get hands-on, Git-based services, get hands-on with it, and you'll learn something, and it will just stick to that muscle memory. Understanding network, you could go into miles of detail around this. Actually, the resources that I used here were some great sessions from another community member who's done a lot of networking how-tos. Not just the ones that I chose here around, say, the OSI application or the OSI layers. But yeah, he's done a lot of content that I basically took for my notes, and I'll make. There's nods to him throughout the throughout the networking section. So big picture, what is net DevOps, or you might have seen network DevOps, and it's basically bringing that automation and living and breathing the same processes and principles that we have from a DevOps point of view. That continuous wheel has to sit there with the networking team as well. So a big part of this is by breaking down the silos between teams. So again, that started with dev and ops and breaking down that barrier between. Networking also has to be involved in that. They have to change to a similar model and process, or they become the bottleneck. Now, it's fair to say here would be a good point to say, well, what did we miss out of the last, or out of this 90 days? And a lot of that was around security. I didn't really hone in on that. And there's a good reason for that, because you could easily spend another 900 days on security. And actually, that'll be the focus of the next 90 days. In my head, if I've got time, that'll be the area that we go to. Just a nod that it doesn't matter what your networking knowledge, you'll know that DNS is always the issue. Okay, so I mentioned about sticking to one cloud provider. In this instance, I went out to the Twitters and asked, well, which one should I cover? And basically, as a big picture, is we need to understand not just the cloud provider, but we also need to understand that on-premises, and that will depend on where you've come from as to how much you need to dive into that. We need to think about infrastructure as a service, so that will be the virtual machine that lives within the public cloud, and you might then look after the operating system, the back-end code, the runtime, the application. But really, the hypervisor, the servers, the storage, the physical layer is not your problem. You're paying Azure or any of them the privilege of taking that admin away from you. Then we go to platform as a service, which abstracts even more of that away. So where you're running databases as a service, you're not going to look after the Windows patching or the operating system. You're not going to look after anything around that. You are literally just going to be consuming databases as a service. And again, you're going to pay for that functionality, or that the reduction of what you don't need to look after. And then you can go SaaS based, think about Microsoft 365, think about Salesforce, where everything is taken away and you literally just have access to the software, and that's what you get access to. Using Git effectively. So how many people are using Git would be my question if I was out in asking you and I could see everyone. How many people are using GitHub? Let me know somehow, whether you're watching it on YouTube or whether you're watching it as a session. Let me know if you are using. I would strongly expect, even as an operations or infrastructure administrator, systems admin, you're probably dabbled a little bit in one of those, and without knowing, you might have used some of those Git commands. But the benefits here are the ability to track a project's history, manage multiple versions of a project. Think about that as a PowerPoint presentation that can be used for multiple events and different personas. We might have different branches for different events or personas. And that's my key part there. Is it's not just for source code. I've used this as my whole backbone and way of being able to version control this whole repository. Yes, there is some code in there, but it's not a project. It's not an application. There's obviously a lot of different code bases in there. I would also really, as a backup technologist, I would say that version control is not a backup. So let's start thinking about how that source code is also protected as part of our daily backup routines. I've got some interesting stuff to potentially share about that later on in the year as well. If we think about version control, we might have main, we might have then a feature branch to that. We then might have that feature that needs to come into the main software. And then we might make that our new branch or our new version of our product or our project. So again, this is me massively diluting everything I did for the 7 days there. I go into a lot more detail about what version control is, how it maybe was beforehand as well, like using other systems that made this process really long. And that's probably why we're seeing, instead of seeing that 6, 9, 12 month plus release cycle on software, Git and version control and Git-based services enables us to release faster. So I think that's fair to say is that whereas the old ones just made things a little bit more complicated. Container-wise, so we talk about Docker because I think everyone knows about Docker. Think about that. Not just Docker, though. There's obviously other ones out there. An ecosystem of images that are easy to find and use, simple to get on your systems and get up and running. They're a very, very small footprint. A lightweight, standalone executable package of software that includes everything needed to run an application. Code, runtime, system tools, system libraries, and settings. And container images become containers at runtime. Now think about that for a second. Like, we've all used .exes, we've all used binaries of some description. And we download that from the internet and we hope, or we run that through an antivirus program. Now, think about that as a marketplace. Think about just being able to take any of those .exes and now have them as a container image, and we run them as and when we need them, either as standalone container images, or we run them inside a container orchestration engine, which is up next. And I believe that that is definitely the way in which we're going to next see the new binary of the future is 100% going to be containers. What do they solve? Yeah, I'm not going to get into this, but you can definitely look at distribution, installation, operation, the benefits of those, why they do it, what's good about it, and dive into some of those areas. This is just a snippet from one of the pages within that section. If we think about it at a very high level, it's the abstraction of the operating system. Virtualization allowed us to abstract the hardware and allowed us to run more on one particular physical system. Containers allow us to run multiple runtimes on the actual same operating system. So we're going further up the stack and abstracting more of that. The advantage of that, and I'm obviously spending a little bit more time here, containers help package all the dependencies within the container and isolate it. One thing I mentioned, it is easy to manage the containers, the ability to move from one system to another. Containers help package the software, and you can easily ship it without any duplicate efforts. Containers are easily scalable. Now, that's true to a degree. Some of those are true to a degree until you get out of the realms of being able to scale. Think about a web server, for example. Yep, you can easily run a web server container locally using Docker Desktop and great stuff. Where that gets difficult is where you want to scale that out so that 1,000 people can access that, or 1 million people can access that. That's where container orchestration really hones in, and in particular around Kubernetes. Don't get me wrong, there's other container orchestration engines out there, Docker Swarm, HashiCorp have Nomad example, but Kubernetes is by far winning the race if it hasn't won it already. So think about taking those Docker containers, and this is me just basically saying about the different variants that we have out there. Manages the deployment, the placement, and the lifecycle of those containers. It also has many other responsibilities. This is going to worry about your cluster management. It's going to federate the host into one target. It's going to schedule. It's going to be your scheduler. It's going to be your service discovery. It's going to ensure that you've got replication between your number of nodes, and it's going to spread the workload evenly across all of the nodes. It's also going to make sure that things are healthy. Basically, you're going to have your orchestrator, so you're going to have a control node, and then you're going to have your worker nodes within that. And the worker nodes is where your workload or your containers, your web server, for example, is going to be spread across your worker nodes, whereas your control plane is going to look after your cluster API. Again, we can get more into the weeds around Kubernetes as a basic form and the building blocks around that in another video. But ultimately, within our control plane, we have our etcd, our key value pair database. We have a control manager. We have a scheduler. We have our Kube API server. Now everything goes through that. All of the communication within the control plane goes through that. We use something called a CLI to access our Kubernetes cluster called kubectl. Multi-operating system allows us to automatically connect into that API server. Doesn't need to be kubectl. There's other ways, but without getting into it. Then each of our nodes has the ability. We have kubelet and we have a kube proxy. Think about that as the heartbeat and how we actually schedule our containers. Then we have a container runtime, namely Docker, or could be container D, or something along them lines. And this is what we touch on during the repository. And then on the node, we can have various different ways of deploying that container. Now, that container can be part of a pod, could be part of a deployment where you might have multiple pods, a front end, back end. You might have some stateful workloads within there. One of your containers might be a forward-facing front-end stateless website, and another might be a Mongo database with an external storage volume. And then you might have a daemon set which lives on each host or each worker node within your cluster. Again, extremely quick coverage of Kubernetes there without getting into the detail. Learn infrastructure as code. This is, I would say, if you're not sure where to start and you don't want to start with programming language, you've got a good understanding of everything that we've covered so far, is make sure that you know IAC, infrastructure as code. I use Terraform, HashiCorp Ambassador as well. So big fan of Terraform, works cross-cloud, multiple platforms and providers. Why? Well, we make mistakes. Humans make mistakes. Automation is the way to go. Think about this. Think about, I want the same way to deploy a developer infrastructure or a developer environment the same way in multiple different locations for 100 different developers. If I did that manually, I would definitely make a mistake, or it would be a long, painful process. By automating that, we can simply do that very quickly using something like Terraform, but I'll call out Pulumi there as well. How do we build the systems today? How do you build the systems today? That's the question. What would you do if you lost everything today? You lost all your infrastructure. How would you rebuild it? What would that look like? How long would it take? We can use code, or specifically here, infrastructure as code, to rebuild our entire environment. That's the idea around infrastructure as code. So Terraform is a tool for building, changing, and versioning infrastructure safely and efficiently. That is actually from HashiCorp. If you think about what that flow looks like, it's written in its own language, HCL, and it allows us to deploy over all of those different platforms that you see there: Kubernetes, AWS, Google, Azure. If I want a Kubernetes environment for demo purposes, I always use Terraform. Simply because I know that I can go Terraform plan, Terraform apply, and then once I'm done, to avoid the costs, I just go Terraform destroy, and it's gone. That gives, and it also gives some more benefits to that, and obviously not everyone is demonstrating stuff as well, but really that is a key part to that. This is how HCL works. Again, I get hands-on with this. There's a couple of examples, and in particular, I use VirtualBox, which is not necessarily, you're never going to be running VirtualBox in production, but this is really, again, a nod to that learning in public and making it available and accessible for everyone within the community. VirtualBox is free to download onto your system, and we can use it here to deploy and start getting to grips with some of the HCL code around that. Automate configuration management. So configuration management is the process of maintaining applications. So think about infrastructure as code gets us to a point, and then configuration management allows us to put a desired state of an application on top of that. Now, there are some blurred lines. Ansible does allow us to also leverage some of the basics of infrastructure as code, and so does Terraform. Terraform allows us to sometimes dive into or deploy a virtual machine, an application, and allow us to do some of that. There's some crossover, so you don't have to. There's some blurred lines there. Configuration management is the process of maintaining applications, systems, and servers in the desired state. If we look at what that looks like, and simply put, again, what we do within here is we're going to deploy a simple web server, and we're going to just make sure that it's up and running and available to us. Now, if we went into that web server and we changed that HTML welcome message to hello world, that would see that desired state, and it would make sure that it went back to 90 days of DevOps. So it's all defined within code versus us going to the web server and changing what that looks like within the HTML file. Creating CI/CD pipelines. Now, think about this. We also showed some of this at the very beginning. This is about how CI is you're creating software. CD is we're deploying software or delivering software. A CI/CD, continuous integration, continuous deployment pipeline, implementation is the backbone of the modern DevOps environment. Now, from a DevOps-focused engineer point of view, we're not necessarily, again, we're not writing the code, but we will have to put the CI and the CD, and they don't have to be exclusive. You might use something like Jenkins from a CI point of view, and you might use Argo CD as your delivery method. That all depends on the application, the coding, the developers, etc. The platform in which you want your application to run on. But the importance of CI/CD, so we're going to be building the infrastructure or the platform that enables us to do that. It enables us to ship that software quickly and efficiently. So rather than that 6, 9, 12 plus months release cycle, we're probably going to be now looking at every 2 weeks, which is what we do at Custom. It allows us to facilitate and be effective and have an effective process for getting applications to market as fast as possible. Again, same thing, allows us to ship software quick. A continuous flow of bug fixes and new features without waiting for months, years. All in all, TLDR, it allows us to ship quickly and efficiently. It allows us to test quickly. It allows us to make sure that we're shipping good quality code. It allows us to implement really small updates versus having to wait for a whole train of new software features and functionality. If you think about, just to describe it, we've got our developer, they're writing code, they're putting it into Git, they're then building that, and then they're testing that, and then they're uploading that good version to Docker Hub. That's your CI. Then they're releasing that, and then this is where it could be two different. It's not exclusive. Like, you don't have to buy or go out and implement a CI/CD workflow. Now, Jenkins does allow some of that, and I use Jenkins in the hands-on tutorials because it's kind of the de facto from years gone by. Now, I would generally move towards something more cloud-native focused, such as Flux or Argo CD, which I also get hands-on with. So if we think about then our end user, and this is where the bottom box here is where I believe a large majority of sysadmins are going to start using CD pipelines, where we're just going to take it off the shelf from a Docker Hub or an image repository. We're then going to use that to update and deploy to our staging, to our production, to make sure that it's all good there. So that's really the CD element to that. Okay, two things left. Observability, which we can think of metrics, logging, and tracing. In the repository, I called this monitoring. I then transitioned it a little bit within talk tracks like this to really focus on observability, because we do talk about quite a lot of different areas of metrics, logging, tracing, monitoring, and all things like that. There, if you're an expert in this area, you're going to screw your face up a lot for these 7 days, but it's going to give you, it's going to give most people a foundational knowledge of, well, what are we talking about and what's important. It's basically keeping a close eye on the entire infrastructure, including, obviously, the application. How do we make sure that everything is running as it should, and displaying that in a usable and visible way? Making sure everything's good, making sure that if there is something bad, how do we automate, how do we fix that? Then finally, around storing and protecting your data. Now, I do talk about backup here. I talk about different open source projects. I talk about a few different variants here. But I think it's also important, and maybe this should have been its own section. I talk about databases here. Data management is not a new wall to climb. It doesn't matter what platform. I've mentioned physical, virtual, cloud, cloud native, and whatever's next, serverless, functions, etc. We're still going to have databases or some sort of data service that we need to protect. So it doesn't change. Kubernetes does not take away the requirement of backup. Is data more important today than 5 years ago? I'm going to let you answer that. I believe it is. I feel like everything is about data. Data is valuable, and it is also ever changing. We also have bucket loads of it. which is a session title that I'm thinking about using, because obviously buckets S3. I'll leave it there. But ultimately, the big picture is that I know I've left it until last because I didn't want to start with it because it didn't make sense to. But it's important that it's in this list, and it's important that we raise awareness of this as a fact, that we also need to shift left, and we need to have this awareness from a developer, from an operations, from a DevOps point of view, that data, from an accuracy point of view, consistency and security point of view, that data is massively important to the business. It's no longer IT, as we know, is no longer at the bottom in the basement. It's very much making the business decisions. Okay, so just about wrapping up here, hopefully just under the hour, is what we're going to do next. So the next phase looks like, well, what are we missing? That's my ask to you as a community. What are we missing? I already know that we're missing a lot about security, things like secrets management, just in general, where does security weave into that DevSecOps, like continuous everything. So, but just give me that feedback wherever it is. You can find me on Twitter at MichaelCade1, blah blah blah. But also wherever that, it's important that what are we missing, because we're all going to be at different levels of our journey. Don't worry about that. That was for an internal event. What's next? Now, I got asked about an ebook. We could do that. Anyone could do that. We use Pandoc. We could put it to PDF. Is that useful? Does people want that? I feel like it's better just in a repo in one single location. But if we want that physical book, does anyone really want 700 pages worth of this that could constantly be changing? I mean, I would ideally want that to be free and sponsored by someone that I don't have to pay or you don't have to pay. Is it useful? Let me know again. Where do we go next? You kind of get the idea that 90 days of DevSecOps will potentially land in the same repository. Key part there is that we're not going to create a new repository for that next one. It will be alongside this one. So all you have to do is continue to watch this repository. And like we're doing here, is we're creating that YouTube content so that we can get to that a different audience, or to the same audience. Not everyone's a reader. These are 90 blog posts with a lot of hands-on. YouTube gives us the ability to reach a wider audience within the community. Okay, so what do we do? What's my biggest ask? I'm not going to say thank you just yet. Get learning, get involved. You can see here, this is an old video. This is an old screenshot. I think we're up to nearly 17,000 now from a stars point of view, and probably over 400 watching. 2,500 forks. That's the name of the game from the repository point of view. It's free, it's open. I want everyone to learn something from it, then it's useful. The QR code will get you there. Contact details down below at MichaelCade1 on Twitter. If not, you're going to be probably watching this either an internal bit of content, or it's going to be on YouTube, which there should be comments down below if you want. Contributor wise, we've broken the 50 already. Generally, a lot of them are going to be spelling mistakes, but also, as I said at the start, it's about contributions. Like, if you feel like I've missed something, not explained something right, let me know. We can talk on a PR, we can talk on an issue, we can talk in a discussion board. Like, let's use Git for what it is, as well, from a project perspective. And yeah, with that, hopefully it was useful. I know it was a bit of a long one. Generally speaking, I want the others to really be well below the hour mark, but you can see how we can get carried away talking about some of these areas. Yeah, let me know. Thanks.